Hello guys, welcome to a beautiful Herrenteich Airfield here in southern Germany. The fog here is just lifted over the airfield, so it will be a bit of time until we really get going. So I wanted to take the time today to introduce you a little bit to what you see behind me. This is a Pilatus Porter. We use it here for skydiving, and actually I got a few requests. This just shows a bit about this aircraft. So I want to take now half an hour or so to give you a bit of a walk around of it. As I said, what we have behind me is a Pilatus PC-6 Turbo Porter. It was originally intended as a STOL capable, so short takeoff and landing aircraft for all kinds of aerial work. And was specifically designed to have a high useful load and be able to carry a lot of weight and a lot of volume also into short and unimproved strips somewhere in the mountains or wherever it's difficult. Nowadays, most of these guys are used for skydiving, because getting in and out of steep valleys, like high climb and descent rates, that also is good for skydiving, and also having a good cabin volume and a good load carrying capacity. So that's what we use this one for. So the full designation of what we have behind me is a Pilatus PC-6 B2H4. So the B2 stands for the engine model. This is in this case a Pratt&Whitney PT6A-27 Turbo Prop, and the H4 is the weight variant, which in this case means it's the highest weight variant with which is a maximum takeoff weight of 2.8 tons metric, so 2,800 kilograms. It's a conventional gear airplane, so as you can see, the third wheel is at the back, so normally referred to as a tailwheel aircraft, and as I already said, has a turboprop engine up the front. Can carry in our configuration up to 10 jumpers to altitude. So let's do a quick walk around and see a few of the features of it. For the walk around, let's start all the way at the front with the engine. So we have here a PT6 A-27, which has 680 horsepower thermodynamic power, and here is limited to 550 horsepower, so we can take 550 horsepower out of the engine. The engine is driving a 4-bladed hard steel propeller. There's also variants of 3-bladed hard steel, or even a 4-bladed composite prop on it. So this one's just a standard aluminum prop. Here at the front we have the big air intake, which also houses in the middle the oil cooler, and then the air actually goes in here, goes up, goes then through the engine backwards, so it's a reverse flow, and then exits through these exhaust stacks, and then the engine drives a gearbox, which drives then the propeller. So if you look from here, you actually see that it's a rather long nose. So this is because it was originally intended as having a piston engine. So late 50s design was originally came out with a piston engine, which is of course a lot heavier for the given power. So when they put a turbine engine in, they had to put it further front to keep the center of gravity the same. And they could have redesigned the whole fuselage to be longer, for example, but they choose not to and just put the engine further forward. This, I think, in my opinion, makes it better looking than the piston variant. I mean, she will not win a design award, so it's more a, let's call it a purpose-built design. But she has a lot of character, I would say. So I quite like the look of it. So let's continue from the engine further towards the massive landing gear. So as you can see, we have rather large main wheels. I actually cannot tell you the size of it. It just says that the tire is made in Great Britain, so I'll probably find out later. So the landing gear, it has 3 massive struts which attach it to the fuselage. The bottom ones have kind of a triangle shape, and they are attached to the center fuselage. This is all able to move freely. What absorbs the impacts from landing is actually this massive shock strut here. So this whole thing here is a massive shock absorber, which is able to absorb a lot of impact energy. There's nice videos from Pilatus where they just hoist the whole aircraft up to a couple of meters and just drop it fully loaded, and it doesn't even bounce. So it just drops to the ground, just one gentle squat on the shock struts, and everything's fine. So yeah, it's really hard to bounce this aircraft, and these things absorb a lot of energy. So it's very nice for off-field operations and rough and unimproved fields, so what it was intended for. So it's really great going off airport with this thing. So for stopping power, we of course have reverse thrust from the engine, but we also have 2 massive multi-cylinder disc brakes on both sides, of course. So let's move on to the wing. So it's pretty standard construction for a STOL aircraft. So it's a high wing with struts, which carry part of the load, makes it a very light construction, and keeps the wing out of harm's way. 2 fuel tanks in one in each wing. The fuel tanks are able to carry in this particular example 480 liters in total. There's variants of bigger tanks, and you can even put fuel tanks under the wings in kind of pods like you see in fighter jets. So, but in general, the wing itself is rather standard. So it's a full aluminum construction, so no fabric covering anywhere. There's no leading edge devices or nothing. So as I said, nothing special about the wing, other than that it's rather big. So we have a 15.8 meter wingspan and a rather large surface area. So gives a nice big clean wing for low wing loading, and this gives her all the short approach takeoff speeds and makes her really STOL capable. So let's move on from the wing to the control surfaces. So here we have the aileron. It's a massive counterweight here to balance it, and there's also tabs on the end of the wing which move on the end of the aileron, which move together with the aileron to help with the control forces. So these control tabs, which you'll find again on the tail, they really help the control forces, make it really light and easy to control. So there's not a lot of muscle involved, even though there's no power assist on the controls. So yeah, but it's also slotted, the aileron, to help with low speed control when you have high angles of attack, and to keep the flow over the control surfaces going. Let's move on to the flaps. I'll move a bit back so you can really appreciate how big they are. So you can see they span about half, or a bit more than half of the wing. So they're quite large. They're also dropped hinge construction, so they move backwards and down when you extend them. So they also extend the chord of the wing a bit. I think they move up to about 38 degrees. So I just put the camera up here so you can see the angle. So these are massive barn doors, which create a lot of drag, but also create a lot of lift. So you can probably see here they are double slotted. There's one slot here, another slot here, which makes them very, very effective at slow speeds. So they really help you to get a lot of drag for you, so you can do a very steep approach, even without the use of beta thrust from the engine. Well, not beta thrust, so beta from the propeller of the engine. So even just with the drag of the flaps, you can do a very steep approach, and this is what you see in a lot of these YouTube videos of the Porter. And well, they also add a lot of lift, so it gives this 2,800 kilogram aircraft a stall speed of 52 knots fully loaded, which is quite nice. So yeah, pitot tube here. And if you move to the fuselage, we see the doors here. So standard back in the day, we had on the left side just a normal swing door, just open one segment, you cannot open fully because of the flaps. So let me check over here. So one big door on this side with two segments, which open outwards, and there's a sliding door on the other side. And the sliding door is what the jumpers use. Yep. The newer version, I think, have a standard two sliding doors, one on each side. Makes it a bit more sexy, I guess. Okay, let's move back from the wing to the tail surface. So you can now also see the tail is also rather large. At least for an aircraft that size, it's rather large, and and rather thick profile on it. And also if you look at the horizontal stabilizer, you can probably see and appreciate that it has an inverted wing profile. Put you a bit here. So if you just compare that, the top and the bottom, you see that there's a lot of curvature on the bottom and rather flat on the top. So it's basically an inverted wing, which creates a lot of downforce here in the back, or is able to create a lot of downforce. Most aircraft I know, they have just a symmetric profile here on the tail. So as far as I know, the reason is that if you come back here for a second, you probably see that I mean, where I'm standing is probably the center of gravity, somewhere below the main wing spar, and basically there's only the front row of the pilot seat, front of the CG, and all the cabin, all the weight you put in, up to 1 ton in the cabin, is behind the CG. So when all that weight from the cabin is gone, you need enough control authority in your tail to bring it to a 3-point landing attitude. So that's where you need all that downforce for. The cabin is empty, a lot of weight from the back is missing, so you need to replace it with aerodynamic force. So yeah. Apart from that, the tail is pretty conventional. So you have a fully trimmable horizontal stabilizer. So this whole surface moves. It's hinged at 2 hinges here at the front, and there's one electric trim actuator in the back, which just moves the whole surface up and down. Probably see it if I put the up. You can see the actuator here. So yeah, pretty standard. A big elevator at the back of the stabilizer, again with tabs to help with the control forces. Now let's move down to the tail wheel. You can probably also see it's a rather massive arrangement with again a big shock strut here, big shock absorber also for the tail, and yeah, very sturdy construction. So yeah, it can take the beating of airport landings quite well. It's not the biggest tail wheel if you compare that. I mean, I think a lot of guys have that size tail wheel on their Super Cubs when they're really doing off-airport work. But I mean, I trust the Swiss guys so that they have it engineered pretty properly to be the right size to handle all that abuse. Sorry, I had a little interruption from the skydivers, so they're now starting to pour in. So we stopped with the tail wheel. Again, massive shock absorber, able to take a lot of abuse. So let's move on from all the stabilizer, from horizontal stabilizer to the vertical one. Again, a massive rudder, which has a massive trim tab running the whole length of the rudder, the actuator being here, and yeah, also the vertical fin. Rather big, which is also needed to counteract the massive torque from the engine. So yeah, that's pretty much a quick walk around. The other side is the same. Just one more little detail. There's a little door here on that side in the fuselage. This is not a cargo compartment. It's intended to store your equipment. So you can put a tow bar in there. You can put the seats in there. So if you arrive somewhere, have seats in, you flown passengers, and you have to fly cargo now, you can remove the seats from the cabin, store it back here. So you can carry all your equipment without sacrificing cargo space in the cabin, which is again pretty neat. Yeah, and that's pretty much it for our tour around the aircraft. So next, have a quick look at the interior and the cockpit and see what that's like. So see you in a bit. Here we're now on the right side with the big sliding door. Let me just open it for you. So nice Swiss engineering, very smooth. So yeah, the sliding door gives you a big opening on this side to load and unload, and this is like the standard door you use also for the skydivers to get in and out. So sliding door in the air, not a problem. Yeah, and this gives way to the big cabin. We fit 10 skydivers in here, so it looks rather roomy now, but with 10 skydivers plus myself in the front left, it gets a bit cramped. But I mean, I don't care. I have my seat. Yep. So a couple of benches for the skydivers to sit on, and some have to sit on the floor. Yeah, so there's nothing special here. The only thing I want to mention is you could probably ask yourself how I get the door closed when the skydivers are out. There's a neat little thing. It's this stick here I can use to basically I grab it and I put it here around the door handle, and then I can just pull the door closed when the skydivers are out. So I can fully close the door, which is especially nice in winter. So get the door closed, cabin is sealed, put the heater on, everything's nice. And it's also not that loud in the cabin with the door open, as compared to the door being open. So, well, let's crawl in and have a closer look at the cockpit. So, welcome to the business end. Let me just quickly sit down. As you can see, it's pretty standard arrangement, I would say. Let me power her up, and then we can explain a bit more. So, if we start on the left side, we have here just most of the switches. So, the top is mostly for the systems and the engine. The bottom ones is all our lights. Then we continue with the standard flight instruments here in the middle. Pretty conventional, apart from the Aspen Evolution primary flight display. This we put in after the old HSI failed. Let's do a self-test here so we get everything up. Yeah, so while this is powering up, let's just start with the primary flight instruments. So we have here the airspeed indicator. As you can see, stall speed, so with flaps down, beginning of the wide arc, is 52 knots. It's quite nice for that load. Maximum speed, just over 150 knots. So it's not that fast, but that's not what she was intended for. She was intended to get in and out of short strips. Then we have another artificial horizon, which is driven by the vacuum system. We have vertical speed indicator and a second altimeter. I usually have this one on the airport QNH, and I use the one from the primary flight display for flight levels on standard pressure. EDEH indicator, trim indicator, very important. If you miss trim, the pitch trim here on a Porter, it'll kill you. I have the another artificial horizon, this time electrical indicator for nav2 and a clock. So all the standard stuff you have, and then, as I said, the primary flight display here. Airspeed, altitude, attitude. Has a few nice features also for dropping skydivers. If we're flying here, you have a wind indication of the wind, and below there HSI style navigation display, which also shows you the nav points, or in this case the airports around us. It's quite nice to fly with the PFD in Skydive Ops. It helps you guide you into the drop zone quite nicely. Okay, if we move to the middle, we have the engine instruments. We have the torque. It's here given in the PSI, so in the pressure value. That's pressure in the gearbox. Probably read a couple of Pratt&Whitney documents to understand where really this pressure is coming from. I understood it in the meantime, but I don't want to explain it here. The ITT, interstage turbine temperature, so it's the temperature between the two turbine stages. Next row, I have the prop RPM, it's normally fixed at 2000 RPM. This is the gas generator RPM given in percent. Fuel flow, typical fuel flow, about 50 gallons an hour in the jump run. Oil temperature, oil pressure. Below there are a couple of warning lights. I can put the test button on so you can see what we have there. So red warning lights, yellow caution lights, and a few green advisories. Then next one up, the throttle quadrant. This here is the power control lever, as Pilatus calls it, so controlling the torque of the engine. This is the propeller control lever. It's right now in feathered all the way back. as it should be now. Normally stays fixed fully forward. And with the condition lever, which gives you fuel cutoff, so no fuel to the engine, low idle and high idle. Yeah, pretty standard for turboprop. Then to the right we have the avionics, an audio panel, Garmin 430 for navigation, transponder, a second radio and a nav receiver, EDEH and DME. And well, for some added luxury we also have a standby transponder over here on the right. So on the right we have first some controls for the cowl flap for the oil cooler, heating controls, fuel totalizer, which shows you how much fuel you have used since the last reset, battery voltage and battery amperage draw, hour counter, the standby transponder is already set. Below there some additional system switches. Here we just have the anti-ice, which gives you pitot heat. Gives you pitot heat. Heats the sense line in the fuel control unit for the engine, and heats the static ports in the back. Below that some avionics switches, DME selector, which nav receiver it goes, transponder selector, this one's in-up, switch for the primary flight display, and the two avionics buses we have here. Then pretty much the last thing we have on the immediate panel, and I'll power it down now so it's a bit quieter in here, is the trim interrupt. So we have two trim actuators in the back actually. If one of them does a trim runaway and just goes where it moves even though we don't want it to, I can put the interrupt switch here and stop all trim movements, and then trim stops, and I have here a switch for the alternate trim to give me trim control back if I need to have it. Yep, that's the immediate panel. Then of course you have your normal flight controls. So we have the control stick here. It's a bit military style, but I mean you have to push the talk button in the front. This would be an autopilot disconnect. We don't have an autopilot, so it's not used. And you can set up the trim here. Here only the pitch trim is electric. So on other models or optional you can have also an electric aileron trim here. So but here only have pitch trim. Then I'll show you the right side pedals. So that's the rudder pedals. Again, very sturdy construction. You have the, if I move to my feet, you have the pedals. So for the rudder itself is the bottom part. If you move your feet up and push, you actuate the brakes. Then bottom left, the circuit breaker panel for most of the systems, and on the right for the avionics. Then the main fuel cutoff valve, some test button. To the left we have the rudder trim. Now that I have unlocked all the control surfaces, I can put it all the way to the right where it belongs for takeoff, and here I can lock or unlock the tail wheel. It's very convenient. It helps you keeping it straight on the runway. So you shouldn't try to take off with an unlocked tail wheel in the Porter. It can run you off the runway pretty quick. Yeah, that's for the flight controls. One more thing here, that's this thing up here, which is for the flaps. So I have to turn to get the flaps in and out. And I have a little indicator here on the wing. If I move the flaps in or out, you can see that stick move. So that's not the pitot tube. The pitot tube is as I showed you under the wing. Yeah, so that's the cockpit tour. And that also concludes our tour of this aircraft. So next one up will hopefully be some videos of it actually in action. So see you later. Actually, an interesting thing, if we move down below the aircraft, it's actually not that dirty at the moment, which is good. We just cleaned it. You can see that thing here with these hinges. That is actually a trapdoor. So so this thing has standard trapdoor in the bottom. Here it's deactivated, but yeah, it comes as standard equipment. So you can actually, it has normally 2 flaps where you can put, I think, 100 kilograms on each of these flaps to drop stuff out of the aircraft through the bottom hatch. So that's pretty neat. The best feature about this one actually, what I really like as a pilot, is that little thing here. So where you can put all your stuff. This is a little detail a lot of aircraft designers actually seem to forget. When you're flying, you have well, you need something to write, a little piece of paper. You need to put your charts and maps, or nowadays your iPad, somewhere. You maybe put something to drink or to eat if it's a long flight. So no cabin service here, of course. On ferry flights, I'm the only one on board. So that's a neat little detail, that you have something to put your stuff. So thanks Pilatus for that. And this is something I really would like to see in a lot of other aircraft.